When what we think we know is overturned, certainty gives way, and knowledge touches mystery in a new way. This newly uncovered mystery may be humbling and unsettling, but it is the cost of truth. Creative scientists, philosophers, and poets thrive at this shoreline. Physics lives at that edge. It is one of humanity's boldest attempts to understand reality itself, not just the world around us, but the world inside us and the world beyond us. Physics seeks the deepest rules beneath nature, rules that apply everywhere, from the smallest subatomic particles to the largest galaxies scattered across the cosmos. At its heart, physics is the most fundamental science. It challenges imagination with ideas like relativity and quantum mechanics, and it reshapes daily life through discoveries that lead to computers, lasers, medical imaging, and modern technology. Physics is not isolated. It forms the foundation of chemistry, astronomy, oceanography, seismology, and much of modern medicine. Yet physics is not simple because it is easy. It is simple because it searches for the most basic principles beneath everything we observe, principles that govern motion and energy, matter and light, space and time. Through physics, we have uncovered ideas that challenge intuition itself, that time can stretch and bend, that particles do not have definite positions until measured. That certainty is replaced by probability. The Heisenberg uncertainty principle suggests that the universe is not a rigid clockwork machine, but a mysterious landscape of possibilities. And yet, from this uncertainty came extraordinary precision. Advances in electromagnetism led to radio, television, and computers. Thermodynamics gave rise to engines and modern transportation. Quantum mechanics, despite its strange implications, underlies lasers, transistors, microchips, and magnetic resonance imaging. Mystery did not halt progress, it fueled it. Physics is also inseparable from mathematics. Albert Einstein once remarked that the most incomprehensible thing about the universe is that it is comprehensible. The cosmos appears to obey compact mathematical laws, elegant expressions capable of describing stars, atoms, and everything in between. Sometimes mathematics predicts reality before observation ever confirms it. Planets, radio waves, antimatter, neutrinos, black holes, gravitational waves, and even the Higgs boson were all foretold by mathematical reasoning before they were seen. Mathematics is not merely a tool for physics. It is a language through which nature seems to speak. Theoretical physicist Paul Dirac reflected on this deep connection, writing that the rules mathematicians find beautiful often turn out to be the same rules nature has chosen. As time goes on, the boundary between pure mathematics and physical reality appears increasingly thin. Einstein himself reversed the usual scientific process. Rather than observing first and explaining later, he began with mathematical insight and used it to predict how the universe must behave. Decades later, his equations foretold gravitational waves, ripples in spacetime itself, finally detected in 2015, a century after his theory of general relativity. Physics is not just equations on a page, it is a human story. Across centuries, remarkable minds, Isaac Newton, James Clerk Maxwell, Marie Curie, Albert Einstein, Richard Feynman, Stephen Hawking, and many others, dedicated themselves to understanding the universe. They reshaped how humanity sees reality, often discovering that our intuition and language lag far behind nature itself. Today, physicists explore ideas that once belonged solely to imagination: multiple dimensions, parallel universes, wormholes linking distant regions of space and time. Some theories suggest entire universes may exist alongside ours, separated by distances smaller than a grain of sand, detectable only through subtle gravitational effects. Such ideas may sound radical, yet history reminds us how often yesterday's impossibility becomes tomorrow's accepted reality. Physics also forces us to confront profound philosophical questions. Could reality itself be a simulation? As we build increasingly complex virtual worlds on computers, even serious scientists wonder whether our own universe could be an artificial construct, governed by mathematical rules embedded deep within its fabric. Physics does not offer final answers. It offers better questions. Its discoveries provide a framework for exploring both the subatomic and the supergalactic, while its theories allow us to predict phenomena far beyond human senses. It is a field where philosophical speculation sparks scientific breakthroughs, and where mathematics becomes a bridge between imagination and reality. Each discovery expands our island of knowledge and lengthens the shoreline where mystery waits. That shoreline is not a boundary, it is an invitation, and it is exactly where curiosity belongs.